Let's write a counter function. Inside of this function, we'll do a for loop. We'll do let n equals 0. While n is less than or equal to 10, we're going to n plus plus. Then inside of this, we'll constant.log our n, and now let's invoke our function. Our constant.log shows us that we were successful in creating a simple looping counter function. Let's refactor this to use recursion now instead of a loop. The first thing we'll do is comment out our function call here and remove our for loop. And we're going to return counter n plus 1. And we'll pass in an n as a parameter to our counter, and then pass in 0 to our function call. Recursion, simply put, is when a function calls itself. As we can see here, we're returning the result of our own function, adding to the argument by 1 each time. Adding a constant.log here with n will give us the same result that our for loop gave us. However, when dealing with recursion, it's important to understand two concepts of a recursion function. It needs to have at least one base case and one recursion case. The reason why we commented out our function call is if we were to run this function, it's going to enter an infinite loop. This is because we don't have our base case yet. So to if n equals 10, we return our function. Now with that in place, we can invoke our function, and we'll see from our console.log that we get numbers 0 through 10 successfully. And this is because we have our base case if check to stop at 10, and a recursion case to continue until we hit that 10. Now, as a side note, there's no performance benefit to using recursion. In fact, loops are sometimes better for performance. On the other hand, recursion can sometimes be easier to understand. If you struggle to understand what the base case is supposed to be, just think of it as what are you trying to get from this recursion function? In our case, we wanted to create a loop that counted from 0 to 10. So 10 was the goal, and that was our base case. Let's run another example to understand this. Let's say that we had an array of arrays with numbers in them. And our job is to look through the arrays for the number 6. If it's anywhere inside of this parent array, then we need to return true or just the string yes. I've already gone ahead and created this function for us. I've called it find6. It's going to take a list of items, as you can see down here. Inside of it, we're going to say, just start off with initially, it does not have a 6 inside of any of the arrays. For that first set of array, we're going to step through each one. So we're going to get this first array and the second array inside this first for each. And then once we're inside of these two arrays, we're going to for each again, looking for 6. If we do have 6 somewhere in there, as we do on that second inner array, we're going to update our has6 variable, and that's what we're going to return. As you can see here that we get yes. If I change that to 5, our function switches to no. This accomplishes our task, however it's not very dynamic, meaning if we were to add this 6 around another array inside of here, we'll see that our function returns no when we still have a 6 in here and we want it to return yes. In order to accomplish this, we'd have to add another for each loop inside of here, where we say if it's an array, we need to do another for each inside of its contents. So instead of adding more and more for eaches or another type of loop, we can refactor this to use recursion. This entails getting rid of one of the for eaches and adding an additional if check where we say if a is an array, then we need to call this function again, our has6 function, passing in this level of array and assigning its return value to our has6 variable. Now with our console.log, we'll see that we're getting a yes back here, even though we have this third inner array. And it stays yes as we remove it, and goes to no if we get rid of the 6. Our base case, or the goal of our function, was to find the number 6, so this was our base case. We're basically repeating this simple logic over and over for the amounts of arrays that we have within our parent array, which makes our function more dynamic, and it's why it's said recursion can be easier to read and understand than just using loops.